Hello students, welcome to IMS Academy. In this session, I am going to discuss number of problems on analog circuits. Every question is a good question only now. But I will give the concept of each and every one of the problem and I will do here. You also try while I am doing the questions on the board, you try to do, understand the now. If it is matching answer, very good. If you got any doubt, you can send a message, understand the now. Yes, I will start the subject now. This is the first question. What are the states of the three ideal diodes of the circuit shown in figure? But in this problem, certain number of the diodes are connected here. But is asking the state of the diode, which diode is on and which diode is off, we need to identify. The options are given, D1 is on, D2 is off, D3 is off, D1 is off, D2 is on, D3, like that 4 options are given. We need to identify which diode is on. Initially I wish to give when diode will be on and when diode will not be on, that we should know better. But in the problem you need to check at first, the diode is ideal or non-ideal, you check at first. It is clearly given in the problem, all 3 diodes are ideal, given in the problem itself. It is given clearly, all 3 diodes are ideal is given in the problem. 3 diodes, ideal diodes only given here now. So just I want to give information when diode will be on. Suppose I have taken, it contains 2 electrodes, no doubt. This potential we are going to call it as a anode potential, this potential we are going to call it as a cathode potential. Arrow symbol which is given is said to be p-type material. The line segment which is given is nothing but the n-type material here now. Like that symbol is taken here now. Arrow indicates the direction of flow of current, on which direction current will flow. That means always current will flow in this particular direction. I can put the current direction now. Direction of the current is this side. But can you find the current in the reverse direction or not? It won't allow only now. It is a reverse bias. The current, if it wants to come to this side, here given one line segment indicates it can oppose the current in this particular direction. Not allowed, current not accepted this side, current will be allowed this side only. Finally, diode is a bidirectional or unidirectional, means it is a unidirectional only. One side only it can allow the current only, and the other side it can oppose the current only, we can say. Understand now. From that point you can identify which diode is on, and also when the diode will be on here. We can say simple point here now. If anode potential is greater than cathode potential, diode is on. Diode is on, I can say. If anode potential is greater than cathode potential, diode is on, we can say. If the VA is greater than VC, diode is on only. If diode is on, it must be replaced by short circuit. In ideal case, I am giving this is for ideal case. For ideal case, the diode is ideal. Understand now. But in this case, what I wish to say, diode must be, diode is replaced by short circuit. When we can short circuit, sir? If it is forward bias, it must be replaced by short circuit only. Anode potential is greater than cathode potential, means we can say diode is forward bias only now. If anode potential is, next condition we can write, if VA is less than VC, diode is reverse bias, diode is off. Diode is off means diode is reverse bias, diode is off. This is a reverse bias only. Diode is reverse bias or off means what? Not conducting means what is the meaning? If the circuit, if it is a open circuit, when there is a open circuit, it doesn't flow any current only, you can say. That means when the VA is less than VC, we can say very simply, Diode is replaced by open circuit. Diode is replaced by open circuits. These two conditions we are going to use only now to do any question here now, nothing more than that. Understand my point now. But in this problem, which diode is on and which diode is off, you identify from this. It's not required any big calculations also. Very easily we can identify which diode is on. Initially, we can select the what now, this path. D1 is a on or off, we can check it now. But suppose I made an assumption, this is nothing but what now? One must be a grounded only now. This is with 10 volts, it is connected here now. Positive potential is connected to the P-type material. N-type material will be connected to the ground only one side. Now the diode is on or off. If I ask, anybody can say this is forward bias, so it must be on state only. If you are watching this part, this diode is on, forward bias only. Positive potential, what now? Anode potential is a 10 volts we got, cathode potential 0 you got, this is on. I can write clearly now, D1 is on here, understand now. And what about the D3 here you got, the current direction, this current will try to flow this side. When it wants to go this side, it won't allow. Reverse bias, D2 is a reverse bias only here now. Because I gave here now, current will not be accepted by the diode this side. The line segment indicates it can oppose the current only now. So this side no current will flow. D2 will be off. The total current will be diverting this side only now. Sir, what about the D2? D2 will be on or off. You check it here now. Here the D1 is on, I said now this one. Forward bias now. Once it is on, from this point to this point, you check it now. Once the diode is on, it must be replaced by short circuit, I said now. If it is short circuited, what is going to happen now? The total current is going to divert across D1 only now. Short circuited, internal resistance, the diode is 0. Short circuit will allow the maximum current only now. Whatever the current, it comes this side. Whatever the current this side, it comes totally diverting, passing through the D1 only now. It doesn't flow across D2 only now. Why it doesn't flow, sir? Because it is a short circuited only now. Total current is diverting this side. Then D2 comes to what? Off state only possible. This comes to off state only now. This comes to off state. We can write clearly. But I can write here clearly now. Here the directly we can write here now. This is off. Now we can write clearly. Solution is nothing but D1 is on, possible. D2 is what? Off, possible. And D3 also off only possible. This is also off only possible. Finally, which option is correct here now? Option A is correct. We can say this option is correct here now. That option is correct now. Such a way we can tackle this question now. It's a very simple question only now. Understand now. The next question I want to give in your hand. You please try this question. This is also a very simple question by using the diode I gave it now. Anybody can do this question? Can you message what answer is correct in this problem? You try to tackle and give the answer. And before doing this question, just I want to give some information regarding the IMS Gate Academy. Any gate aspirant can join in this IMS Telegram channel here now. This is our join our Telegram channel now. But it is a free YTL lecture. Because of this Telegram, but once the student join in the Telegram channel, what are the advantages they will get? That is required here now. The schedules of the free YouTube lectures. What are the schedules of free YouTube lectures will be received by the student only. The lecture PDFs you will receive, because we are teaching here now analog circuits. Once the class is over, PDF file, that PDF file will be posted in the Telegram channel now. The students can go through the this PDF to do these questions any number of time. Important updates related to the seminars and webinars will be given. And also PSUs and other government job notifications will be given. And expert session on important topics, daily quiz and many more. But the faculties are going to post excellent questions on this Telegram channel now. The students can solve that. If they are unable to get answer, the faculties are going to give solution for that question also. So these are all the advantages possible for the students if they join in the Telegram channel. The next one, the students who wants to take the admission in GATE 25 and 26, what are the program features? You can see them now. The live online program, the around 800 plus hours of the live classes with the live interactions possible, and theory book, exercise book, and 30 years GATE question banks with the video solutions available. That means no need to purchase any textbook, but all the GATE related questions you will see in the exercise book and also GATE question bank. Your preparation is a very good only in the theory book and exercise book in the 30 years GATE questions. That is quite okay now. Understand my point now. 12 personalized one-to-one mentorship sessions possible here now. To give the guidance to the students how to prepare for the GATE, mentoring will be useful. 130 plus online tests with video solutions of the mock test and many more possible. If anybody wants to get any information regarding this GATE 25 and 26, they can make a call to this number and they can get the right information. Understand now? Yes. Now, how far you did this question? Anybody can give answer for the question I gave in your hand? For this question, it's a very simple question. Easily you can do this. Easily you can do. Assume that D1 and D2 in figure are ideal. Specified clearly, diodes are ideal. All the diodes are ideal only. Only 2 diodes are there. No, those 2 are ideal, he says now. The value of current I is, this current is asking how much current is going to flow. You know very well the direction which side it is given current you watch. The direction is given down. But this is the p-type material, you know. This is nothing but the n-type material. I said already, just now I explained. But when the current comes this side, it doesn't allow, diode will not allow. It is a reverse bias only. When it is a reverse bias, it doesn't allow any current. At the time, the current I becomes 0 only now. Now, whatever the current it goes, D1 is a forward bias only now. That will divert only now. We cannot find any current across the D2 only now. Reason is what means it is reverse bias. That's why directly you can write current I is 0 only. You can put the diode is reverse bias. Reverse bias here. If the diode is reverse bias, you know current I is nothing but 0 amperes only possible. 0 milliamperes only. 0 amperes or 0 milliamperes, no problem now. 0 milliamperes it will flow. The finally, which option is correct? If I ask, any student can give answer very easily. No, 0 milliamperes of current is going to flow this side. That is the solution for this question. I hope you followed. Next question. This is one more question from the BJT. Any student can give answer for this. I will wait for some time. You please try this question to give answer. You please try to give answer for this question. I want to wait for some time. You please try this question. I will wait for some time. Anybody can do this question? Okay, I will explain, please watch. In the BJT circuit shown, beta of PNP transistor is 100. Beta is given 100. Assume BBE, this is the base, this is emitter. This is the collector, no doubt. VBE reverse given here now. The current direction is given emitter to base, but reverse is given. Reverse is minus 0.7 volts it is given. The voltage across RC will be 5 volts it is given. That means voltage across this RC is given here. What voltage is given? 5 voltage is given here. This is given 5 voltage. When R2 is dash kilo ohms, that means RC, but now voltage across this 5 volts possible. So in that case, R2 value, how much is asking to find? Resistance R2 is required from this problem. Anybody can say, give their answer? If you are getting answer, you can give what R2 you are getting, but I want to know. But in this problem, I would like to denote symbols. This is a 12 voltage. This voltage is nothing but 12 voltage, no doubt. I'll put it here now. This voltage is given 12 volts. Same 12 voltage you can have. The current which is passing through the RE, I can put as a IE. Emitter current, I can put this side. This is the emitter current. And this current, I can put as a collector current only now. IE equal to IB plus IC possible here now. This is IC value, we can say now. This is IC value. IE equal to IB plus IC possible. This is possible here now. This side IB is possible, this side, understand. Anyhow, this point is the base voltage I can put here now. This voltage is to be taken as a base voltage. But in this case, this voltage I can give you a name of IXB. What is I1 you measure? You will get answer directly. Anybody can find? I give the idea. You can start doing this question now. You start doing this question, I will wait for some time. Anybody can give answer? Anybody can give? This is the emitter current. This is divided this side. This is the base current, you know very well. This current is nothing but the IC one. Now, if I know VB and I1, I can measure R2, VB by I1. So, what is I1? IB plus IX equal to I1 only now. IB plus IX equal to I1 I can get here now. How we can measure all these VB and I1 here now? That's very important. Initially, I wish to find what is IC from the given problem. From the given problem, I can determine what is collector current. I can determine what collector current is going to flow. Voltage across RC divided by VC, RC. 5 by RC is nothing but IC only. 5 divided by RC. The RC is nothing but 3.3 kilo ohms. The 5 by, I can write 3.3 kilo ohms. May know the value of IC? Anybody? What is the value here possible? The value is around, I will give the value. The value of this IC is nothing but, it comes as 1.515. 1.515 milliamperes of current is going to flow. That much collector current is passing through this one now. Sir, why this IC is required? Because my aim is to find the IE at first. Without knowing the IE value, I cannot determine this base voltage. Understand my point now. IC I got. What is IB? You know very well. IC is nothing but, IB is nothing but IC by beta. You can write clearly. IC by beta. Where IC is nothing but 1.515 milli divided by beta. Beta is given or not given, you check it. Yes, BJT, beta of the transistor is given, 100 is given here now. I can put 100 here now. This can be taken now. Now what IB is possible, you put it now. That IB value will be 0 0.01, 0 0.0101 515 milliamperes of current is passing, 0 0.01515 milliamperes. That much base current is possible. Sir, why we have to find IB means, I said already, my aim is to measure the IE value. My aim is to find the IE value. Once I got the IE, how I will find the VB, you watch. Understand? But I can write IE is nothing but IB plus IC, no doubt. IB plus IC you can use directly. IB is nothing but 0 0.01515 milli plus 1.515 milli. Then I can measure what is IE. What is IE value? Its value is, I will give IE value. IE value 1.5303. 1.5303 milliamperes possible. That much emitter current is possible. Add this through, you will get now 1.5303 milliamperes of current is possible. Now here required, why we are finding IE value? Why I got this IE value means, I wish to find the potential at the point of this. I wish to find this potential. What potential I can get here now? This is the emitter voltage I want to take this now. This is the emitter voltage I want to find. If I got VE, VB I can determine. VB is nothing but VE plus VE minus 0.7. Emitter to base to emitter is minus 0.7 is given. But a emitter to base, if it is taken, 0.7 voltage positive value possible. So VE minus 0.7 is nothing but the base voltage only. That's why for the sake of finding the base voltage, I determined emitter current only now. Now we can find what is VE. What is VE here? Emitter voltage I want to find. I wish to find what is emitter voltage. Emitter voltage 12 minus drop across this RE. Supply voltage 12 voltage minus drop across this RE. I can get VE value here now. I can write VE is nothing but 12 minus drop across this RE 1.2K 10 power 3 into IE. IE is nothing but 1.5303 milliamperes of current is possible. Now you can determine what is emitter voltage. What VE you can get from this problem. The emitter voltage comes as, I will give the value. That value will be, if you are using the calculator, you can get VE 10.16 volts possible. That much voltage is possible. That voltage we can say it as a VE value now. We got VE is nothing but that much value now. But a VE, by using this VE, what I want to find here now, VB value I want to find, base voltage I want. The base voltage is nothing but VE minus 0.7. VE minus 0.7, no doubt. VE is nothing but 10.1636 minus 0.7. Now you can determine what its value possible. That value will be, I will give now. .46, it comes like this now, 9.4636 volts possible. That much voltage is possible. The voltage I got because of the subtraction only here now, understand my point now. So why VB we got it now. What about the next parameter it is required in this problem? The current I1. VB by I1 is nothing but R2 only now. How to measure I1? I1 is nothing but IX plus IB only. IX plus IB. So initially I wish to find IX. IX is nothing but current passing through the 4.7 kilo ohms only. I say Ix is nothing but the current passing through the resistor. This resistor only now. Understand now? The resistor only possible. Understand now? The resistor only possible. But how I can find the Ix here? Ix can be calculated like this. I will calculate, you watch. I want Ix value. The Ix is nothing but 12 minus VB. 12 minus VB is nothing but 9.46. 9.4636 divide by resistor. What resistor you got? 4.7 kilo ohms. 4.7 kilo ohms only. Now use calculator, you are going to get Ix value. The Ix value will be, if you are using calculator, its value comes as, I'll give you now. Its value is 12 minus VB by that value. It comes 0.5396. 0.5396 is possible. 5396 milliamperes of current is possible. That much milliamperes of the current is possible. But my aim is to find I1 here now. I1 how I can get? Now please watch how to get I1. I wish to find what is I1 here now. The I1 is nothing but Ix plus IB only now. Addition of these two currents can give I1 value. So Ix we got, try to understand, Ix is nothing but we got as a 0.5396, 0.5396 milliamperes only. 5396 I got. 5396 plus these are all in milliamperes only. 5396. What about the base current you are getting here now? Base current we got as a 0.0015 we got like this now. So addition of these two currents can give I1 value. So finally we got I1 as, the I1 value will be 0.55 approximately 475, approximately some value now. Approximately it comes only, I can say instead now. Approximately I will put now. 47 is enough. That value possible, milliamperes possible. That much milliamperes of current is possible. Then I can determine the required parameter. What parameter is required in this problem? What is asking to find in the problem? R2 value required. VB by I1 can give the R2 value. VB by I1 I can say. So VB by R2 I want. R2 is not, R2 required. VB by I1. VB by I1 I can use. The base voltage VB value we got already. What is VB value we are getting already? 9.4636. 9.4636 we are getting now. 36. What now? Getting or no? 9.4636 now. 4636. Correct or no? 4636 only. Next, what is required now? One more parameter now. One more parameter. Rx means this voltage we got it now. And current is nothing but the I1. I1 we know very well. What is I1 value? I1 value 0.5547 milliamperes only. Now you can use calculator to find the R2 value. R2 value comes as, finally this value will be 17.05. 17.005. I can say 17.05. 17.0592 kilo ohms mostly possible. That much value is possible. Like that, the value of R2 will be made. Followed or not followed? Here it is nothing only now. The problem what I said, we want to find out the R2. R2 how we can get now? Voltage across R2 by current across R2 only. Voltage is a VB, current is a I1. But thereby required VB1, VB and I1 only. How to get VB? You find what is VE value. Once you are getting the VE minus 0.7 is a VB value. How to get VE? VE is nothing but 12 minus drop across RE. But IE value required. IE I can get if I know IB and IC only. I am finding the IC. IC equal to what now? Voltage across RC by RC. What now? RC. Then IC you will measure now. Base current IC by beta you know. By using that you can determine now. Like that what happens now? Determination of parameters are made only now. Understand now? Yes, I will give the next question. You try to do this now. I want to give one more question in your hand. You please complete this question. You please complete this question. I will wait. Is asking to find RB by RC. Can I get answer for this question without my help? But I want to wait for some time. What is given in the problem? In the given circuit, the silicon transistor has beta equal to 75 and a collector, this resistor is not there, no, sorry, it is directly given only, no resistor here, no value. The problem it is given, directly given only. Yes, now correct. In the given circuit, the silicon transistor has beta equal to 75 and a collector voltage Vc equal to 9 volts. Then the ratio of RB and RC is, that he is asking to find. How we can determine these parameters? The name of this network you know very well. Just what now, from the collector to base connection is given. What biasing circuit? Collector to base biasing only. Collector to base biasing is made. We know very well collector to base biasing can give the stability. But anyhow, is asking to find out the RB by RC ratio here required. We know very well the current which is passing through this RC cannot be taken directly IC. This is not taken IC value here. Because this current we can call it as a IC value. And this current is IB value possible. Because of this node point, what happened now? The current is divided only. The finally, what current is passing across this RC? If I ask, anybody can say IB plus IC only. IB plus IC. That much current is passing this side. So here the Vc value is given in the problem. Collector voltage at 9 voltage is given in the problem. Specified clearly, this voltage at 9 voltage is given in a problem itself. The problem itself it is given. So when you know well about this supply voltage here given and this node voltage is given, at the time I can determine IB plus IC directly. Difference of this voltage is nothing but voltage across RC divided by RC. Voltage across RC by RC I want to get it here now. What I wish to say, from the given problem, I wish to find what is IB plus IC. This value I would like to find. This is the current is nothing but the current across RC. Voltage across RC by RC only required. We can determine. Voltage across RC is nothing but the 15 minus 9. 15 minus 9 divide by RC. By RC I can write now. This becomes what? Is a 9, 15 minus 9 means what value possible here now? What is the value possible here now? 16 possible. The value, find it now. Anybody can send that value? That value will be approximately. We have 15 minus 9 by RC we are getting now. Okay, that you can put now that value. Okay, that value you can put now. But here the what is IB and IC we can write now. What is IB means I can write as this. IC can be written beta into IB. I can write beta into IB. Beta into IB possible. The 6 by RC mostly we are going to get here now. 6 by RC value is possible here. The problem clearly given beta value 75 only here now. There I want to take IB in common. I have taken IB in common. If it is taken, I am getting 1 plus beta into 6 by RC I am getting here now. 6 by RC I am getting here now. And I wish to find what is the base current. Without base current, I cannot get the ratio RB by RC. IB is required in this particular relation only now. How I can get the IB value? Just I want to select the path. Just I want to select the path in this direction. Just I want to apply the KVL in this path. So otherwise directly you can write now. IB is nothing but the current across this RB. Voltage across RB by RB only. This voltage you know, this voltage 9 voltage. This voltage drop you know 0.75 it is not given, 0.7 volts we know very well. So base current is nothing but 9 minus 0.7 by RB1. I can write directly. So base current I can determine like this. I can find base current like this. IB is nothing but 9 minus 0.7. 9 minus 0.7 divided by how much? RB divided by RB I can get now. If you are simplifying, it comes as what? 9 minus this. 9 minus 0.7, 8.3 divided by RB is possible. Yes, that much base current we are getting. Sir, what is the point of finding this IB? I can substitute this IB in which equation? Just in the top equation. There I can get now. If I substituted IB value, I can get the relation what now with RB and RC. That equation you will get in terms of RB, RC only now. Then the required ratio you can find. IB I want to substitute 8.3 by RB into what? 1 plus beta. Beta value is given in the problem. What is beta value? 75 is given. 1 plus 75. 1 plus 75 that equal to 6 by RC. This is equal to 6 by RC will now. What is asking to find? Something is given 122.86. Akansha Sharma 122.86. Just to check once again. If it is correct, very good only now. I can check now. RB by RC required. RB by RC is required. That is nothing but 8.3 into 76 divided by 6. Use calculator. What its value? We check it. I'll check this value. You gave how much? 122.86. I'll check. But I think 105.13 or something. 105.13. Please cross check again. 105.13. Akansha Sharma, can you check once again? Is it 105.13? Anybody? What value it comes to check it now? I am asking the other students now. Can you check this value, how much it comes? .3 into 76 by 6. Yes, mostly it comes, I think, 105.13. But if you got 122 point something means okay, no problem, understand. But anyhow, you check, cross check here again, understand my point. Yes, that is the RB by RC process only, I can see, understand now. We can go to next question now. This is one more question. Any student can solve without my help this question? You know very well this circuit is nothing but current mirror biasing circuits. Anybody can solve current mirror? Calculation mistake. Which side calculation mistake? Your side or my side? May I know? My answer or your answer? Which answer is having the mistake? May I know? Calculation mistake on your side or in my answer? Okay, anyhow, you got the idea what is the way to do, understand now. Yes, anybody can tackle this question without my help now? Anybody can tackle this question without my help? Two perfectly matched silicon transistors are connected as shown in the figure. Assuming the beta of the transistor to be very high, beta of the transistor is given very high in the problem, very high is specified. Assuming the beta of the transistor to be very high and the forward voltage drop in the diodes to be 0.7 voltage, the value of current I is asking to find current I. Anybody can find current I which is passing through the transistor Q2? Just to take some time and give answer. If you are getting answer, very good, otherwise I will do. What current is passing? The current I want. Anybody? Yes, option B. Sir, kindly increase the voice. Voice is to be raised. Okay, I will increase now. Is not audible my voice? Is it audible or not audible? Still required? Yes, I will you was. But in this case, beta of the transistor is given very high. This beta of the transistor is given very high. That point is very important. The beta is very high. What we have to assume here now? In the current mirror biasing circuits, you know very well. The current which is passing through this side, this current you got here now, this current I, same I you can have this also. The same I, understand now. This current and this current will be same only possible here now, same possible now, understand now. But this collector current, but now this collector current and this collector currents are same initially now. The beta is given I and I, this current and this current is not same. When these two currents are not same, if beta is given. Beta is not given in the problem. Beta is a very large is specified. Base current is approximately, what now? Neglect, but now approximately what you have to know, whenever the base current is not, but whenever the current of what now, beta is given very large, base current is approximately 0, they will assume now. Anyhow, what I wish to say, this current will pass this side, I will apply the KVL in this path. If I apply the KVL, same I can get now. In the current mirror biasing circuits, this current and this current will be equal. When sir, if it is, if beta is very large only now, then I can apply the KVL. 0 voltage equal to, here I got, this voltage is 0 voltage, no doubt. Solution I can put directly. 0 voltage equal to, drop across this 1 kilo ohm, 1K into I can put directly, plus Drop across this diode is nothing but 0.7, no doubt, given in the problem. When I go this side, some drop is possible here now. When I go this side, some drop 0.7 again. Base to emitter is just 0.7 voltage possible now. And again I can go this side, minus 5 voltage. Minus 5 voltage possible. I wish to find what is I. I is nothing but 5 minus 0.7, 1.4 by 1K is possible here now. Use calculator here now. Its value will be 3.6 possible now. 3.6 milliamperes of current is passing in this circuit. Finally, which option is correct here now? Option B is correct here now. This option is exactly matching only, let's say. Like that we can tackle this question. Understand my point now? Now I want to give one more question. You please try to tackle this question. Yes, this is one more good question. You start doing this question. You can do this question without my help. You can try this question without my help. But I want to give some time to start doing this question. Your work is required initially. Anybody can try this question? Any student can do this? Initially, I want to know answer from your side. Any chance to give answer? Otherwise, shall I do? Tell me. Akanksha Sharma, shall I do this question or are you trying otherwise? If you face any problem, I will start my work. Yes, I will do. Please watch this question. I want to do this question now. In this particular problem, you try to watch, there is a transistor. And also here the one Zener diode is given here now. The Zener breakdown is occurred if there is voltage drop of 5 volts here now. If it is maintained 5 voltage across this Zener diode, breakdown is possible. Breakdown voltage is given 5 volts. Here the breakdown is possible or not possible here now. Zener is under breakdown or not in breakdown. Zener is connected parallel to the any resistance, you know very well. What you will do initially? Zener is connected parallel to the any resistor. Initially, what they will do? Zener is not in breakdown. First assumption we need to make. Zener is not in breakdown one. If it is not in breakdown, this can act as a open circuit. No breakdown, it can act as a open circuit. If it is a open circuit, you measure current across the 10 ohms only. Current across 10 ohm, if you got, you find out the voltage across this 10 ohm. Voltage across 10 ohm, Zener voltages are equal. Zener voltages are equal. 1 minute, yes. Yes, Zener voltages are equal. This voltage and this voltage, whatever Zener voltage across Zener equal to how much? 10 voltage, 5 voltage equal to 5 voltage or greater than 5 voltage we need to get now. What I wish to say, voltage across 10 ohm, if I got greater than or equal to 5 voltage, Zener is on state only. The voltage across this 10 ohm, you got less than 5 voltage, you think it's so. Zener is in off state only possible. Our assumption is a correct only now. So the point what I wish to say, a Zener is connected parallel to the any resistor, you try to assume at first Zener is in off state only. If it is on state, off state, you measure the current across this 10 ohm. The current across 10 ohm and 20 ohm will be same only possible. I will do here, you please watch. Okay, one student is asking to wait for 1 minute. 1 minute I will wait now, otherwise no problem. Okay, you can also try here. I will also do only now. Understand now. I say in this problem, I made an assumption Zener is in off state. Let Zener diode is in off state, is in off. I made such an assumption only, then connected parallel to the any resistor. In that case, this diagram I can plot like this. There is a transistor and this is connected to the what now? There is a resistor, 7K resistor, it is given 7 kilo ohm, 7K I am putting here now. And this is connected to the what now? Some supply, 25 volts here given. This is with 25 volts. Zener is open one now. Here the 10 ohm resistor I got. Here the 20 ohm resistor I got here now. This is a 20 ohm resistor one. These are all connected in this way. Now Zener is not on state, it is off state. We made an assumption. We made an assumption. If it is on, very good only now. Understand my point? Here, this current, this voltage is 25 voltage, same 25 voltage you can have, no doubt. This current is nothing but the base current only here now. Base current of this transistor, because same current is going to flow this side also. Same. You know very well, this current must be emitter current only. Even current across this 20 ohm is same IE only. But the problem is asking to find the current through the 20 ohms is asking to find. Across 20 ohms required here now. Current across 20 ohms. What current is passing across 20 ohms means same IE only. But that IE is a correct or wrong to know, you need to find the drop across this 10 ohm. Less than or equal to, less than what now? 5 voltage you got means our assumption is correct. Greater than or equal to 5 voltage means what is going to happen now? Our assumption is the wrong one now. Understand now? We can check now. Here I want to calculate what is base current at first. Once I know the base current, I can determine how. Just I want to apply KVL in this path. I want to apply KVL in this path. Just I want to apply KVL in this path. This side I can go. But in the problem it is clearly given the Zener diode in the circuit has a breakdown voltage of 5 voltage, no doubt, voltage across this. The current gain beta of the transistor is a 99 is given. 99 is given. Ignore base emitter voltage drop VBE. Voltage across this voltage is asking to neglect. Base to emitter voltage you neglect. That means voltage across this you neglect is saying here now. The current through the 20 ohm resistor in milliamperes required. Asking to neglect voltage across base to emitter voltage. 0 voltage. Then I can write equation like this. 25 volts equal to 25 equal to, when I go this side 7K into IB I can write 7K into IB. When I go this side there is no drop, the drop is neglected. So 10 plus 20 and 10 are in series, 20 plus 10, 30 I can get now, 30 into IE, I will get like this now. But IE I want to convert in terms of what, otherwise you can write IB in terms of IE, you can convert now. 25 equal to 7K, base current equal to, you know very well, emitter current equal to, you know very well, 1 plus beta times of IB, no doubts. To IB is possible. 1 plus beta times of I am writing here now once again. 1 plus beta times of IB is possible here now. So IB equal to, I can write IE by 1 plus beta. Beta is nothing but 99. 99 plus 1, 100 is possible. Plus 30I. Now may know the current IE here. What current you will get here now? What IE you are getting? Yes, 3.35. I will check the now. 3.35 you are getting. I will check now. No, that much current is not passing. Here the 250 milliamperes of current is passing this side. 250 milliamperes. That means 0.25. It comes as a 250 milliamperes of current. 250 milliamperes of current is going to flow this side. That much current will flow. 250 milliamperes, but is asking to find in milliamperes only. I got 250 milliamperes only. 250 milliamperes means 0.25 amperes exactly. Catch my point. Now this the Zener is open is a right or wrong. Suppose you got doubts. Zener voltage equal to drop across 10 ohm. This Zener voltage same only now, parallel only now. So 10 into 0.25, 2.5 voltage only you will get now, 2.5 voltage only. So 2.5 voltage across the 10 ohm, if I got Zener is not in on state only. To reach to the what now on state, it requires 5 voltage only now. We don't have that 5 voltage. So the assumption what we made in this problem is a 100% perfect only now. I mean Zener is true only. Why? Emitter current is 0.25, 0.25 into 10, 2.5 voltage I am getting. So Zener voltage, if you apply the KVL, voltage across 10 ohm is nothing but for 2.5 voltage. So Zener is off state only possible. Assumption is correct. This is answer. Understand now. Now I will give one more question. You please tackle this one. This is the next question. You please tackle this question without my help. You start doing this question. Okay, approximately 2.43, no problem. 2.43. 2.43 is what you are getting? milliamperes will come now. Okay, good evening, sir. Excellent question, sir. Okay, thank you. Yes, anybody can do this question? I will give now. Yes, you please tackle this question without my help. You please tackle this question. Why didn't consider 0.7 volts at the base and emitter end? Yes, it's given you what. You try to read the question. You try to read the question. In the problem clearly given, what is given? Ignore base emitter voltage drop VBE. Ignore is given. Is asking to neglect drop across the transistor. VBE value is asking to neglect in the problem. That is why I neglected. Followed, Akanksha? Did you understand or not? Did you understand or not? Followed or not? In the problem itself directly given base to emitter voltage, you ignore. Ignore is asking. That's why we are neglecting that voltage. Understand my point now? Okay, very good. Next. Yes, so please try this question without my help. This problem you try. What answer you can get? You please try this. Sometimes asking in the gate this model questions. But I will wait for some time. You please tackle this. Anybody getting answer for this question? This is also current mirror, but resistance R is given. Resistance R is given. Resistor R is given in the problem. But two types of the current mirror biasing circuits you will find in the problems without R, with R they will be. Without R and with R. Without R we have done problem already. With R, whenever the R is given like this, there is a formula for that. There is a formula. But the circuit shown in the figure uses matched transistors with a thermal voltage Vt equal to 25 millivolts. Thermal voltage Vt given 25 millivolts. Okay. The base currents of the transistors are negligible. These two base currents are negligible, he says now. The value of resistance R in kilo ohms that is required to provide 1 microamperes bias current for the differential amplifier block shown in the figure shown is dash. Is asking in the problem, you find what is R, is asking to find the R value. This current is 1 microamperes, this collector current only now. This collector current is nothing but 1 milliamperes it is passing now. How we can determine? This current is to be taken as a IC1 value. Generally, they will use this is nothing but IC1 value. This current is to be taken as a IC2 value. So, now the formula I am giving, when the resistance R is given, this formula applicable. Resistance is not there, directly you can do Darlington amplifier, current mirror biasing circuit already done. Understand? R how to get here now? That formula is nothing but R formula is there now. R equal to thermal equivalent of voltage by IC2 into ln of natural log only now. IC1 by IC2. There is a direct formula. Sometimes asking questions of this model. When you are asked to find out the resistance R, you will get only now. But how that resistance R you are getting that formula means you know very well, I think now. Just this voltage is nothing but the VB, this voltage is a VB1. By applying the KVL in this direction, VB1. This voltage is nothing but the VB2. VB2, base to emitter voltage 1, base to emitter voltage 2 is possible here. But generally you will say VB, but not base to emitter voltage 0.7 sir, this also 0.7 sir, no. These two voltages are not same here now. VBE1 and VBE2 are not equal in this circuit. The reason is what means base to emitter is still connected with what this transistor still connected with a resistor only now. That means suppose you have taken this point. These two are in parallel, this voltage and this voltage if it is taken exactly comes parallel only now. Base to emitter voltage of this transistor, this side when the KVL is applied, VBE2 plus drop across resistance. This voltage drop plus VBE2 is equal to VBE1 only. VBE1 equal to VBE2 plus R, drop across this R. By using that analysis will be made only now. But here I am not using that formula derivation and everything now. Directly I am calculating now. So, whenever you are finding, otherwise directly you can write now, whenever the resistance R you are finding in the problem, directly you apply this formula only. How we can determine these values of R? R is calculated like this. Thermal equivalent of the voltage given 25 millivolts. 25 milli. Directly I can write. IC2 is nothing but this value IC2, 1 micro. 1 micro I can write. ln of natural log. IC1 is a 1 milli. 1 into 10 power minus 3. IC2 is nothing but 1 micro. 1 into 10 power minus 6. Use calculator and find the resistance R. Find the resistance R. These are Widlar circuits they will call generally. By using this Widlar current mirror circuits, The calculation will be done like this. What is the value of this R? Anybody may know? The resistance R you got. What resistance R is possible here now? That value comes as 172.172. 172.7 kilo ohms mostly possible. That much resistance is possible in this problem. That much value possible. Any others getting same answer here? Anybody has done this question? Anyhow, this way you need to do this question. Understand this now. And I wish to give one more question in your hand. You please try it without my help. Yes. This is one more question. It's a very simple question. Easily you can do. Logically you complete. You complete this problem. I will see how many number of students are going to give the right answer for this question. How many students are going to give the right answer for this question? 172 point, last problem you say? 172.7, okay, very good. Kilo ohms, is it not? Is it kilo or not? Akansha may know, is it a ohm or kilo ohm? It comes in kilo ohms, am I correct? The resistance, the resistor value, the Harshavardhan, yes, very good, Harshavardhan Sharma, 172.69. I am asking now, ohms or kilo ohms I am asking. That value is ohms or in kilo ohms you are getting. 172.69 ohms or kilo ohms I am asking. Anybody? Is it in ohms or kilo? Yes, kilo ohms. That's required. That's all. I don't want anymore now. Very good, very good. Exactly getting. Very nice. Yes. Yes, anybody can do this question without my help now? Without my help, you please try this problem. I'll see how many students can give. What its value? What value is asking in the problem, you check it. It's kilo ohms, exactly, kilo ohms only, that's correct only. Very good, very good. That only, I got in kilo ohms only. I gave answer in kilo ohms only, 172.7 kilo ohms, perfect. What you did is right. It's an acceptable answer. Yes, to try this question. Anybody can give answer for this question? Shall I do? Yes, it's a very simple question. In the circuit shown below, what is the output voltage in volts if a silicon transistor Q and an ideal op amps are used? Ideal op amp. This op amp is a ideal. Is asking to find the V out. Output voltage, how much is asking now? V out is asking to find. What is this V out is asking. But how we can do this question? It's a very simple question. I said how we are going to do this, you watch. I wish to apply the KVL here. KVL I will apply. How the KVL is applied to find the what now V out? Just I will apply this KVL like this. That's all, enough. That way we can do. Sir, C is correct or B is correct? You check it once again. You should apply the what now? The K, I am applying this side. KVL, I will apply this side. If I apply the KVL in this direction, how the equation is forming, you watch. This voltage is a 0 voltage, no doubt. This voltage is a 0 voltage, no doubt. Grounded one now. When the KVL applied, 0 voltage is equal to this voltage plus V out. I say 0 volts equal to, when I go this side from base to emitter, 0.7 voltage, not given. 0.7 we can put if not given. When I go down, plus V out, KVL I applied 0 voltage equal to 0.7 plus V out. Then what is V out? Yes, it is a B is correct, exactly correct. B is correct. Yes, correct. So V out is calculated directly. That value is nothing but minus 0.7 voltage. So which option is correct? Option B is correct. 100% option B is correct. That way we can do. Problem is not complicated, very simple. Yes, I want to give one more question. You please try. This problem you try to do. Please give answer for this question. You start doing this question. You can start. You can start doing this question. But I want to give some time. You please try. If you are getting answer, very good. Otherwise, I will do, no problem. What is final answer? Anybody? Please tell the internal polarity of op-amp. Here not given here now. Yes, sorry. I will give now clearly. It's the same only polarity. It won't be changed. This is a minus, this is a plus, no doubt. But this is the plus, this is the minus. Now quite okay. Now perfect. This is perfect now. The polarity is that only now. Minus plus, this is plus minus only. Those two are with negative feedback only, no doubt. They were all with negative feedback. This is with negative feedback. This is with negative feedback, no doubt. Both are with negative feedback. Yes, I will do. Please watch. What way I am doing this question, you please watch. You can also try, no problem. In the circuit shown below, the op-amps are ideal. Clearly given, those two op-amps are ideal. Then V out in volts is output voltage in volts required. Output voltage required in volts only. But ideal op-amp means you know very well. If the op-amp is ideal, V plus and V minus are same. You can have the same voltages only. V plus value, V minus value will be same only possible. I say, what I say, for ideal op-amp, you know, this voltage and this voltage same. But what voltage I can have here? V plus is nothing but same one voltage I can have. The same voltage you can have, V minus also same one voltage one. Same voltage, one voltage only possible. Understand now? Anyhow, this is a 1 voltage, this is a 1 voltage. Yes, one student gave 1, 4 something. Yes, I will check now. I will check. We can check what answer it comes. This voltage, 1 voltage, this is a 1 voltage only now. But you should not say there is some drop across 1 kilo ohm. No, impossible. You cannot find any voltage drop across 1 kilo ohm. The reason is what? For ideal op-amp can have input impedance of very high, infinite value. Input impedance of operational amplifier is infinite for ideal case. When the input impedance is infinite, current passing through the 1 kilo ohm is a 0 only now. 0 amperes of current is going to flow through the what now 1 kilo ohm. Reason is what? Input impedance is very high. Current is 0 means same 1 voltage I can find here now. There is no drop across 1 kilo ohm. Yes, I will check now. This is a 1 voltage, this is a 1 voltage. Even this voltage also same 1 voltage. But I wish to find initially this voltage Vx or V1. V1 we can find. By using the nodal analysis, I can find what is V1. By using the nodal. Nodal means what now? Away from the node you put the direction. Away from the node I will put the directions. This current plus this current equal to 0 I can write clearly. In that case, nodal whenever I applied, I will get like this now. What I will get here now? 1 minus this voltage, how much not specified, that must be given only now. But how you are giving the value without knowing that value? That voltage must be given only now. I didn't take that value, I think now. I will check once again. I will check that value. This voltage 2 voltage given, sorry, this is a 2 voltage, it's a my mistake only now. This voltage is nothing but the 2 voltage only. Without this supply voltage it cannot work, that will not work, understand. But how you are giving 4? Without this voltage it won't work, understand. Must be required only now, 2 voltage given here now. So in that case solution what I can take now, this current is 1 minus 2 by 1k. I will write 1 minus 2 by, according to the nodal, 1 minus 2 by 1k here, plus according to nodal. Then sir, V naught by 2. What is V naught by 2? What is V naught by 2? No, I am saying no, this voltage is given only. I made a mistake now. This voltage is given 2 voltage only, given in the problem only. I didn't put there now, understand now. It's a 2 voltage. Anyhow, 1 minus 2 by 1k, this side current is nothing but 1 minus V1 by 1k. 1 minus V1 by 1k, that equal to 0. As per nodal, Catch my point, this voltage is given, this node voltage 2 voltage. Given only, understand. 1 minus 2 by 1k, this current 1 minus V1 by 1k, that equal to 0. K cancel, here I am getting the minus 1 plus 1 minus V1, 0. Finally, V1 equal to what voltage I can get now? 1 minus 2 minus 1 plus 1 minus V1. V1 comes as a 0 voltage. V1 comes as a 0 voltage. If V1 is a 0 voltage, 2 voltage, 0 voltage means directly you are getting totally 0. It won't work only now. Okay, this is a 0 voltage I am getting now. This voltage I got 0 voltage. I am putting here now. This voltage is given 0 voltage. If it is 0 voltage, same voltage I can get here now. Same 0 voltage I can get this side. Same 0 voltage I can get here now. It is a 0 voltage. Is it going to function here now? Is it going to function? It doesn't work only now. V out is not possible here now. Voltage divider formula, if I applied, V out 0 voltage only I am getting now. 0 voltage means what I can get now? I can't get now. V out becomes a 0 because voltage across this 0. Same what now? Drop is possible here now. Finally, V out also same 0 voltage possible. 0 voltage. Sir, options are not there now. Options are not there means I made the what now? That voltage only wrong I think now. Just let me check it once. Let me check it once again. I will check that voltage. Sorry, that's why now minus 2 voltage. Yes, now perfect. Last one. This is a minus 2 given. This is given minus 2. As I didn't select properly that value, it came like this. So finally, you watch it. 1 minus of minus plus 2. This becomes a plus 2 only. It becomes very simple. Plus 2 possible. 1 minus V1 by this. I will complete, just watch, easily I will complete. It's nothing is now. Unnecessarily because of that voltage, it came that mistake. Otherwise nothing is problem. I will do, you watch. 1 plus 2, 3. 1k cancel, plus 1 minus V1 is possible. That equal to 0. V1 equal to, it comes 4 voltage. V1 4 voltage. The V1 is a 4 voltage, you watch. This is a 4 voltage. If it is a 4 voltage, what happens, you watch. If it is a 4 voltage, same 4 voltage you can find here now. I can apply what now? Just I can apply the what now? Voltage division formula. Then I can get answer. Voltage across this. According to voltage division formula, I can get like this now. V0 is nothing but voltage across this 1k, 4. 4 equal to V out into voltage division formula I am applying. V out into what? 1 by 1 plus 1, 2 possible. So finally, V out equal to how much possible? 8 voltage possible. Yes, 100% perfect. 100% perfect. 8 voltage is possible. The mistake what I did means I didn't take that value. Instead now, please convert that as a minus 2 voltage. That's a perfect now. Instead, this is perfect. Anybody has taken this? Which option is correct? Option C is correct only. We can see. Followed this? If anybody having any doubt, please arise. If there is any doubt, you can arise. Sir, C is correct. Now C is correct only. Perfectly it is correct. What you gave me now. Now I will give you one more question. You please try. Yes, this is the problem I am giving. This is a very good question. The same model question 2 times asked on the gate. Same model. You can start doing this question. Start doing this question without my help. I will wait for some time. Anybody can get answer? I'll check who is getting answer. I'll check. Just I want to wait for some time. Anybody getting answer? If you got answer, please tell me. I will check. I want to check. Any student? Okay, I will do, please watch. But what is given in the problem, you check it. A transistor circuit is given below. The Zener diode breakdown is 5.3 voltage. That means a drop across the Zener is a 5.3 voltage is given directly, as shown in the figure. Take base to emitter voltage drop to be 0.6 voltage is given. That means the drop across this transistor is given 0.6 volts. It is not given 0.7. This voltage is given 0.6 voltage only. That voltage is given 0.6 voltage. Next one, the value of current gain beta is asking to measure the beta value. That means the current gain which is available for this common emitter configuration equal to how much is asking. How to get beta value here? I can use like this now. I can do like this now. The current passing through the Zener is given 0.5 milliamperes, strictly given. Current through the Zener is given 0.5 milliamperes, clearly given in the problem itself. So how I can measure the beta value? You know very well this beta value, this node voltage we know very well. This node voltage we know very well. Voltage across Zener is nothing but this node voltage only. That voltage I can put 5.3 voltage. Same 5.3 voltage I can put here now. That much voltage. And what is this emitter voltage I ask, for example? This is the emitter voltage only. Voltage across this emitter. The current passing through this side is nothing but the IE value. IE value. But I wish to measure initially IE value. You may ask a question, sir, what is the need of finding these IE, sir? IE equal to, you know very well, 1 plus beta times of IB. IE equal to 1 plus beta times of IB. Beta, it comes only from the emitter current only. That's why that beta, if I want to measure, IE required and also required base current also. This current also required. This current also required. The current passing through the Zener is given. This current I want to denote by the symbol IX. This IX is divided as a IB and this current to the Zener 0.5 milliamperes only. So where from we have to start our work? What is emitter voltage? Emitter voltage I can get like this now. I can get emitter voltage like this. I can get emitter voltage is nothing but 5.3 minus 0.6 is VE only. The emitter voltage is nothing but 5.3 minus 0.6. I can write 5.3 minus 0.6. You calculate its value, how much it comes? What its value it comes? This value is around, what is the value possible? 4.7 voltage possible. 4.7 voltage possible. That much emitter voltage we are getting now. So what is the point of finding that emitter voltage? To measure IE. IE I can get from emitter voltage divided by emitter resistance 470. Emitter resistance 470. So we got VE is nothing but the 4.7 voltage. You divide by 470. Then you can measure what is IE. What IE you are getting, you tell me now. What IE you are getting? It comes as 10 milliamperes, it comes 10 milliamperes of current is possible. Now why, but after getting this IE, because you know IE equal to, I said already, emitter current can be written as a 1 plus beta times of IB. If I know the base current, I can find beta value. Without knowing the base current, I cannot get beta. So how to get the base current here now? IX equal to 0.5 plus IB only. So if I know IX, I can measure IB. How to measure this IX? That is more important. How to measure IX? IX is nothing but the current across 4.7 kilo ohms. That is nothing but 10 minus 5.3 by 4.7. I say IX is nothing but 10 minus 5.3 divide by what resistor? 4.7K divided by 4.7K 10 power 3. May I know the value of IX here? 10 minus 5.3 by 4.7K I say. What is the final value? Anybody? It comes as 1 milliampere only. Check it. 1 milliampere it comes. This comes as 1 milliampere only. This will be 1 milliampere now. Understand now. 1 milliampere it comes. Correct? 1 milliamperes mostly possible. Yes, we got. What is IB? IX equal to, I can write IX equal to IB plus current passing through the Zener. These two addition is nothing but IX only. So plus 0.5 milli, you know, but I wish to find what is base current. IB is nothing but IX 1 milli, 1 into 10 power minus 3 minus 0.5 milli, and finally base current equal to how much here now? It becomes a direct you can write now. This current you know already, IX 1 milliampere, 1.5 means 0.5 only goes, no doubt. 0.5 milliamperes it passes. That much base current is possible. But using this base current, I can measure this beta now. This beta. IE is nothing but 10 milliamperes. 10 milli. That equal to 1 plus beta. Beta we need to calculate. 1 plus beta into IB. IB we got already. What is IB value? 0.5 milliamperes. 0.5 milliamperes. 10 power minus 3, 10 power minus 3, here you can cancel. And what is still left here? We are getting here now still beta is nothing but 1 plus beta equal to 10 by 0.5, 20 possible. Beta is nothing but 20 minus 1. Finally, beta is nothing but 19, I can say. That is the solution of this question. Beta equal to 19. That is the solution. Anybody having any doubt regarding this solution? If you have any doubt, you can ask. You got a right to ask. I am ready to clarify your doubts. If there is any doubt, you can arise. 19, perfect. Perfect only now. Harshavardhan Sharma getting 19. Yes, same answer. What about Akansha Sharma? What about you? What you are getting? What answer you are getting? May I know that? Akansha Sharma, what about you? What you are getting? Yes, I want to give one more question in your hand now. I wish to give in your hand. Yes, one more good question I want to give. You please try without my help. Yes, you complete this question. You please try this question. Take time and give answer. Take time and give answer. Start doing this question. You can start doing this question. Anybody? Which option is correct? Please start doing this question. Anybody getting idea? Anybody getting idea for doing this question? Yes, I will do this question. Please watch. Try to understand how I am doing this question. The 3-terminal linear voltage regulator is connected to a 10 ohm load resistor. This is nothing but the linear voltage regulator, this circuit. 10 ohm load is connected. What is the power dissipated in the transistor? How much amount of the power is dissipated by the transistor? Power dissipated by the transistor is calculated by what formula? Generally, you know this current is the collector current. Everybody knows. The voltage between these two is nothing but the VCE. Power dissipated by the transistor is calculated by VCE into IC, voltage into current. You must use this formula. The power dissipated power dissipated in the transistor. I want that can become, that's a P, dissipated power. We can write as a what now? VCE into IC. This formula you must use. If you know what is IC and VCE, then you can determine. Otherwise, we can't get it. I can say one more way. This node voltage is nothing but collector voltage. You know very well. This node voltage is a collector voltage. This node voltage is this voltage or this voltage same, emitter voltage only. I can write this as a emitter voltage, VE value. The difference of this voltage can give VCE. So we must know VC, we know directly VC equal to 10 voltage. But I should know what is VE. Otherwise, I can't get it. The VE, this voltage VE means even this voltage also VE, no doubt. Even this voltage also VE only. So between these two, this voltage we know very well, 6.6 volts only. 6.6 voltage. VE is nothing but 6.6 minus drop across this. This is a 0.7 only possible. 0.7 only possible. So 6.6 minus 0.7 is nothing but the emitter voltage I can get. Once I got VE, I can determine VCE value. I say once again, I am repeating here. I am repeating once again. VCE is nothing but collector to emitter voltage is nothing but VC minus VE. VC minus VE. I can write like this. Understand now? But a VE is nothing but, I can write VC is nothing but, first of all, VC is nothing but 10 voltage only. Same voltage, 10 voltage I can write. This is 10 voltage. What about the value of VE, sir? VE is nothing but 6.6 minus 0.7. Minus 0.7. The finally VE equal to what I can get here now? What I can get? 5.9 I can get now. 5.9 voltage possible. 5.9 voltage I can get. Then I can determine what is VCE. VCE I can get directly. VC is nothing but 10 voltage, you know. VE is nothing but 5.9. The difference of this voltage, how much possible? 4.1 voltage possible. Yes, we are getting VCE 4.1 voltage. Now you please try what is IC now? I got the value of VC. Now can you say what IC is possible from this network? What IC is possible? You start doing this question. I'll see. At least can you complete that or not? I want to know. I want to know how you will complete. You start doing this question. You can start doing this question. I am getting 4.1 voltage. That's correct only now. But I am in need of this IC also. How to measure IC? Yes. Anybody give me? Say option D is correct. 5.4. I will check. I will check. Option C, option D is a 5.4 volts. I'll check now. I think there is a mistake, I think now. Okay, I will do, please watch. We got VCE value. But I want IC also. This current is nothing but IC. You please watch, you can understand clearly. This current is IC. What configuration it is? It's like a common base configuration. Common base, it is required alpha value. Alpha is not given in the problem. If it is not given, we need to assume it is a maximum value IC. That means otherwise you can say very simple way. In common base, IC and IE are approximately equal. Why I can take approximately equal, sir? Because the alpha or beta not given in the problem. When it is not given, we need to assume these IC and IE are approximately equal. These two parameters are approximately equal. When, sir? When alpha or beta not given in the problem. So, how to determine this IE emitter current? That's more important now. Anybody can find what is the emitter current I can get here now? What emitter current I can get here now? Please find what is the emitter current here possible. Anybody can do this? But this current is a IE here. You find, you please tell me this current, how much possible? This current is nothing but this some current I will get, this I1 or something. This current is nothing but this some I2 I have taken, for example. Current passing through the load is nothing but it I2 I have taken. Current passing through the 1 kilo ohm I have taken I1 only now. So I1, this is a I1, that means IE plus I1 equal to I2. IE plus I1 equal to I2. Then IE equal to I2 minus I1 I can use. That way I can come. To find the emitter current, I1 and I2 required. I can get I1 directly. 6.6 minus VE by 1K. Otherwise, this voltage 6.6 minus this means otherwise the drop across base to emitter is a 0.7. Same voltage drop you can find across 1 kilo ohm. Same 0.7 parallel. So I1 is nothing but 0.7 by 1K. Directly you can write. I say I can find I1 in this way. I can find I1 in this way. What way I1 is possible? 0.7 by 1K. 0.7 by 1K I can write. It becomes 0.7 milliamperes of current is going to flow. 0.7 milliamperes it is passing I1. What about IE, sir? IE is nothing but, something is written, 1.29. What is 1.29? Yes, I will do now. I2 is nothing but VE by 10. I2 is nothing but VE by 10. I can write VE by 10. Emitter voltage by 10. VE is nothing but, we got already VE. VE is a 5.9 divided by 10. It becomes 0.59 amperes of current is passing this side. I can determine what is IE. IE equal to what? I1 plus IE. I1 plus IE equal to I2 only. Then IE is nothing but I2 minus I1 I can write directly. I2 is nothing but 0.59. I1 is nothing but 0.7 milliamperes. 0.7 milliamperes possible. You measure what is IE. What IE is possible. It comes as 1.29, correct? It comes as 0.59 minus 0.7. It comes as, I will give, that value will be, this value is approximately, it comes like this now. Zero 0.589 milliamperes of current, sorry, amperes of current is passing. But milliamperes means 589 point something it comes from, Anyhow, 0.589 milliamperes possibles. Then you can determine directly what you have to determine. IE and IC are equal, I said. IC is approximately equal to IE, I said. Then you can find power dissipation across the transistor. VCE we got as a what? 4.1 voltage. And IC is nothing but 0.589. 589. Use calculator. How much? What is the value it comes to, tell me? Approximately what you are getting finally? It comes as 24 watts, it comes around 24 watts, approximately 24 watts it comes. 24 watts it comes. 24 watts it comes now, exactly. 2.4 watts or 24? 2.4, sorry, 2.4 it comes. reverse value possible. So finally here which option is correct means B option is correct, 2.4 watts it comes. So option B is correct here now. This option is correct now. Option B only correct. That way we can get answer. Follow this. Any students are having any doubts regarding this question? If you have any doubt, you can ask me. You can ask if you got any doubts. This way we can calculate 2.4 watts possible. 2.4 very perfect. Harshavardhan Sharma, you are correct one now. Yes, I will give one more question. You please try this now. You please try this. Yes, you please try this. I'll see how many students can do this question. It's a very simple question, but you can do, I think. You identify what logic is there in the problem and get answer. You please tackle this question. I will wait. Anybody can do this question? Any student can do? Any student can respond? Is it possible to get answer? If it is not possible, I will do, no problem. If not possible, I will do, no problem. Yes, option D, yes, exactly correct. Option D is 100% perfect. Yes, very good, very good. But what was asked in the question? The silicon diode shown in the figure has a barrier potential of 0.7 voltage. It is given a silicon diode shown in the figure has a barrier potential 0.7 voltage is given in the problem. There will be no forward current flow through the diode. That means current through the diode is a 0 possible. No forward current is possible. When if VDC in volts is greater than, the VDC is greater than, VDC in volts is greater than, that means VDC is greater than what voltage if you got, this current will become 0. When current is going to become 0 through the diode? If it is a reverse bias. If it is a reverse bias means what you have to do, anode voltage of this diode is to be taken as 2 voltage only. Cathode voltage is to be taken as a VDC by 2 only now. The difference of this voltage is less than 0.7. Not ideal, non-ideal diode it is. Non-ideal diode. Non-ideal means what I can write now? Anode voltage minus cathode voltage must be greater than 0.7 voltage possible. 0.7 voltage for non-ideal. For non-ideal diode. Non-ideal, I say. Non-ideal diode. If it is a non-ideal diode, because it is a non-ideal diode only now. So that condition must be satisfied here now. But here how we can do this question means please watch, you can understand. If this condition is not satisfied, if this condition is satisfied, what happened now? Diode is on. This is allowed. Diode is on. For diode on state only. For on state that is required. But it is required off state only. No forward current is given. No forward current. No forward current means it is off state only. When it is off, you can write clearly like this now. Clearly you can write. The forward current through diode no forward current through the diode is said. That means no forward current. Forward current through the diode is 0 possible. When, at what condition? When diode is reverse bias. When diode is reverse bias. Diode is reverse bias. If it is a reverse bias, it doesn't flow any current. That point very important. But in this case, I can write clearly anode voltage 2 minus, condition I can write like that now. VA minus anode minus cathode must be less than 0.7 required. Less than 0.7. Then only it won't be operated only now. VA means 2. BC means VDC by 2. Must be less than 0.7 is given. Then it won't operate. Diode is reverse bias. Then current through the diode is 0 only. I want VDC in volts is greater than what value? Greater than only. I brought this side 2 minus 0.7. This side I brought VDC by 2 I can take. So VDC is greater than 2 minus 0.7 into 2 only. And finally VDC is greater than, is a 1 point, what is possible? 1.3 into 2 only. And answer is VDC must be greater than what value? 2.6 voltage possible. That much voltage possible. VDC must be greater than 2.6 volts only now. That means option D is correct here. Option D is correct in this problem. This option is correct. Yes. Sir, I am Mr. Avinash Kumar, I don't have an idea about the Hindi. Hindi I can't speak, I cannot understand. If you are giving information in English means you message in English, English is required here now, otherwise I cannot understand. You are saying something now, I don't understand what you say, understand now. Avinash Kumar, I am repeating now, I don't know Hindi. You send something now, I don't understand what you said, understand. Okay, anyhow, I am doing the next question now. You please try this question without my help. You please try this question. Anybody can find its value? Whatever is asking, that you find it? You find the value is asking. Is asking to find something. You please try. I want to wait. Very less number of students, but even there are the less number of students, they can they can watch later on, is it not now? This video they can watch this video later on, is it not now? Some students may be busy, so whenever they are getting the time, they can open and they can watch this video. Understand now? That energy will not be wasted here now. 100% it will be useful to the every student only. Understand? We must try our best. Understand? Yes, anybody can do this question? V1 minus V2 required. What is V1 minus V2? Difference of this voltage I want. Difference of this voltage is required. Anybody can find? In the given figure, transistor T1 and T2 have identical characteristics. VC is set of a transistor T3 is 0.1 voltage given. 0.1 voltage is given. The voltage V1 is high enough to put T3 in saturation. It is going to keep this T3 in saturation. Voltage VBE of a transistor T1 and T2 and T3 is 0.7. Base to emitter voltage is given 0.7. The value of V1 minus V2 equal to how much is asking? The difference of the voltage is asking V1 minus V2 required. Anybody can find V1 minus V2 from the given problem? Anybody can find V1 minus V2? What is the difference of voltage here possible? Any student? It is a current mirror is there now. Current mirror principle is possible here now. Current mirror biasing circuit, this and this. What current is going to flow this side? The same current is going to flow in this direction also. It won't be differ. Same current will pass. Harshavardhan Sharma, 4.98 volts. Yes, I will check 4.98 volts. You are agree? I will check. I'll check their value. But I don't know, I will check otherwise now. I will check that is best now. Understand now. 4.98 you are giving. I will check, no problem now. But initially I wish to find this current I. The same current is maintained this side. Just I want to apply KVL in this direction. I'll apply KVL in this direction. If I applied KVL, I can measure I. This voltage drop is nothing but 0.7 volts. 0.7 voltage possible. So when I applied the KVL here, the 9 volts equal to, otherwise the current across this 5K is nothing but I. I can say the current passing through 5 kilo ohm is nothing but the I. The I can find, yes, 4.28. I will check, no problem. I will check now. I is nothing but, the current I is nothing but 9 minus, the drop is 0.7. 9 minus 0.7 divided by 5 kilo ohms only. Divide by 5K. 9 minus 0.7 is nothing but 8.3. 8.3 divided by 5K. It becomes 5 ones, 5 6, 1.66 milliamperes of current is possible. 1.66 milliamperes of current is possible. Correct this? 9 minus 0.7 by 5K. 9 minus 0.7, 8 by 3. 5 ones, 3.3 means 66 milliamperes possible. That much current now. Same current is maintained, this also now. But I wish to find what voltage is existing. What voltage is existing at this node I want to take. This voltage we can say easily now. This voltage is nothing but the emitter voltage VE I can say here now. In the problem clearly given, transistor T3 is in what saturation. If it is in saturation, this voltage is given 0.1 voltage is given here now. From here to here voltage is given 0.1. So emitter voltage is nothing but VE is nothing but, I can write clearly, emitter voltage is nothing but 9 minus 0.1. 9 minus 0.1, it becomes 8.9 voltage only. Emitter voltage is nothing but 8.9 voltage I got. That much voltage I am getting here now. But I want V1 minus V2 only now. Is it not now? V1 minus V2 required now. Understand? Otherwise directly you can measure. I think this step also unnecessary thing now. Otherwise directly I can get, still easily you ask, still easily I can get now. Still easily. Emitter voltage also unnecessary. Without that you can't get now. Just apply the KVL in this part best. Just apply the KVL. V1 equal to from here to here drop is 0.7. When I go down 3 into I plus 3I, this side I have done plus V2 only, plus V2. I want V1 minus V2. 0.7 here plus 3I, I is nothing but 1.66, 3 into 1.66 milli, 10 power minus 1. Then V1 minus VT you determine. What is V1 minus V2? Yes, you calculate. It comes in volts. Understand? That way we can find out. V1 minus V2, 0.7 plus 3 into something is possible. You will get something good. That way we can calculate. Thank you so much, sir, for these conceptual questions. Feeling quite confidence after the attending your session. Kindly take more sessions like this. Thanks a lot, Akansha Sharma. Thanks a lot. See, yes, some students will be like this only now. They are what now? Satisfying with the subject only. That is required now. Okay, then now. Next problem I will give now. Yes, anybody can tackle this question. It's a very good question. This is one of the good question. Any student can do this one. Any student can do this problem. Any student can do this question. Any student can get answer for this question without my help. Good evening, good evening. Anybody can tackle this question? The problem is given like this. In the circuit given below, assume that VCC equal to 15 voltage, Z1, Z2, Z3 and Z4 are identical Zener diodes. All Zener diodes are identical, he says, with the breakdown voltage of 5 volts. Voltage drop across the each Zener diode is given 5 volts. R1 equal to R4 equal to 5 kilo ohms, R2 equal to R3 equal to 10 kilo ohms. Find V0 when Q1 is off. Q1 is off means when transistor is off, you find out V0. Is asking to find V0 when transistor is off. Anybody can do this question? Anybody can do this question? How we can find this value? Start doing this question. I give the concept. Transistor is off. When the transistor is off, you find it. Understand? Hi sir, good evening, good evening, good evening. Anybody can do this question without my help? Yes, the problem it is given certain parameters here now. What those parameters are given, you please watch. BCC is given as a 15 voltage. This voltage is given 15 volts. This voltage is given 15 voltage. The Zener diode breakdown is given 5 voltage only. All the Zener diodes value, what now voltage is same only now, 5 voltage only given. VZ1 here given, VZ1 equal to VZ2 equal to VZ3 equal to VZ4 equal to how much? 5 voltage only. The voltage drop across each Zener diode is given 5 voltage. They were all connected in parallel. These two are in parallel, these two are in parallel. So, same 5 voltage is maintained here now. Understand? Same 5 voltage now. But in this problem, what I wish to say, when the transistor Q1 is off, when it is in off, what is going to happen? There is no current across this Q1. Across this transistor, it doesn't flow any current only now. Why it doesn't flow? Collector current becomes 0 only here. This current becomes 0 only. When 0 it is possible, but here it is given when Q1 is off. When Q1 is off. But the current will try to flow this side and will try to come to this side. Some current is diverting this side. Some current will divert this side only. And they will try to go this side or this side, parallel only anyhow. That's possible now. But the point what I wish to say, when the transistor is off, if it is a V0, even this voltage also same V0. Even this voltage also V0. Even this voltage also V0. This voltage also V0 only possible. But the problem is asking to find V0 value only now. Yes, somebody, Akant Sharma, C option. C 10 voltage you are giving. I will check now. 10 voltage. Yes, 10 voltage is a perfect, 100% perfect only now. You are getting very perfectly that value. Yes, 10 voltage is possible. So, whenever it is a off, V0 only now. Just I will apply the nodal analysis. This current plus, this current plus, this current equal to 0. This side no current only now. As per the nodal, I am doing here now. As per the nodal, I am doing here now. So, according to the nodal, I can write this current is nothing but V0 minus 15, V0 minus 15 divided by what I can write V0 minus 15 by R4. What is R4? 5 kilo ohms. R4 is given 5 kilo ohm. Plus summation of all the current 0. V0 minus Zener voltage. V0 minus Zener voltage. Parallel means same voltage. That is a 5 voltage. V0 minus 5 divided by R2 by R2. What is R2 given? 10K is given here now. 10 kilo ohms it is given. Plus one more current is passing now. Which side? Which side? Yes, exactly correct. Akant Sharma, you are correct. Exactly correct now. C option is correct now. And next one is that this current will flow. V0 minus 5. Yes, I got V0 minus 5 divided by V0 minus 5 divided by R3. What is R3 here? R3 is a 10K is given here now. R3 is a 10K. That equal to 0. You try to simplify this. If you are simplifying this, it comes V0 equal to what voltage? 10 voltage. It comes exactly correct now. So, it comes 10 voltage only. So, which option is correct here? If anybody asks, option C is correct only, you can say. The option is correct now, you can say. This is correct now, understand? Option C is correct only now. Like that we can complete this question now. And I wish to give one more question now. I'll see how many students will do. That's all. This is the question I want to do. As this is the last question for today class. For this section, this is the last problem. By this problem, I will close. You please do this question. This is the last question for today class. You please try this question without my help. Without my help, you can complete this question. What is given the problem? In the circuit shown below, all the components are ideal. If Vi is 2 volts, the current I0 sourced by the op amp is dash milliamperes. Is asking to find I0. If R2, R3 equal to 10 kilo ohm, and they are given the voltage value, that is a 5 voltage. If they given the voltage value, that is 5 volts, then yes, you are using the Hindi I cannot understand. That's my drawback. I cannot understand Hindi. Can you write in English? They have given the voltages values. There is a 5 voltage, correct up to this. Okay. Then next to you, I don't understand what you have written. Can you write in English? I cannot understand Hindi. Just to try, 100% I will give answer. The question is what clearly you give me. I don't understand what you are giving. Arshavardhan Sharma, 2 milliamperes. Yes, I will check now. 2 milliamperes. I will check here now. The Vi is given 2 volts here now. Vi is given 2 volts. If Vi is a 2 voltage, you know very well, even this node voltage also same 2 voltage only now. Same 2 voltage only now. This is the last question, understand. But it is going to flow current of some current, this side it can flow. I wish to take that as an I1. This current I want to take it as a I2 for example. I1 plus I0 equal to I2 only here now. This is I1 plus I0 is nothing but I2. Then you can determine what is I2. You can determine what is I2 here now. Sorry, I0 you can determine. How I can get this voltage is nothing but the output voltage, you know very well, V0. I wish to find V0 at first. Without knowing the V0, I cannot do this question. How I can do nodal? I can use. Nodal means this current plus this current equal to 0. So this current is 2 by 1K, 2 by 1K, 2 by 1K plus this current. This current is 2 minus V0 by 1K. 2 minus V0 by 1K I can write. That equal to 0. That equal to 0 possible. And finally 1K cancel. V0 equal to what is possible? 4 volts possible. V0 is nothing but the 4 voltage. Yes, again given 6 milliamperes. We can check now, no problem. V0 equal to 4 voltage we got now. The V0 equal to 4 voltage means you can measure I1. First of all, this current I1 also. V0 if you got I2 you can measure directly. I2 is nothing but V0 by 1K. V0 by 1K. V0 is a 4 by 1K. It becomes a 4 milliamperes only. This becomes 4 milliamperes. Sorry, sir, 1. Yes, no problem. I will check, no problem. Very good. The 4 milliamperes we are getting I2 value. And what about the I1 values are? I1 is nothing but 2 minus V0, 2 minus V0 divided by 1K, divided by 1K, I can write. 2 minus V0 by 1K, I can write now. So V0 is nothing but, V0 is a 4, 2 minus 4 divided by 1K. it becomes minus 2 milliamperes possible here now, minus 2 milliamperes possible. I can write this current is I naught plus I1, I naught plus I1 equal to I2 only possible. But my aim is to find I naught, I2 minus I1 I can get. I2 is nothing but, what is I2? We got 4 milliamperes. Minus I1 is nothing but minus 2 milliamperes we are getting. 4 plus 2, 6 milliamperes possible here now. Final answer is 6 milliamperes of I naught is possible. 6 milliamperes, yes, Akansh Sharma, you are getting 6 milliamperes, that's right, exactly correct. So for today's sessions, these are the problems are possible. Tomorrow I am going to do the one more session based on these analog circuits. Try to attend and get some idea on analog circuits. Okay then, thank you.